Here we're going to be taking a look at something called the Intermediate Value Theorem. The Intermediate Value Theorem seems relatively intuitive, but it has some pretty intricate parts to it that need to be satisfied in order for us to apply the Intermediate Value Theorem. So the Intermediate Value Theorem says if f is continuous on the closed interval from a to b, and we're told that f of a is not equal to f of b, so like the y values are not the same value at the endpoints, and n is any number between f of a and f of b, then there exists at least one number c in the open interval from a to b such that f of c is equal to n. Okay, so what is required here? So first, f has to be continuous. We have to have f of a not equaling f of b. N needs to be between f of a and f of b. And if all of that happens, then we can say that there must be some number c in an open interval such that f of c equals n. Now really, what is all of this saying? So all this really says is that if a function is continuous, then it will take on all of the y values, between f of a and f of b, between the starting and ending point of our closed interval. And then this figure here illustrates the Intermediate Value Theorem. So here we have a, right? Here we have a, here we have b. So in order for us to get from a to b, our function's continuous, so we have to be able to draw this entire thing without picking up our pencil. Now we've picked some arbitrary value in between f of a and f of b. We called it n. And in order to get from here to here in drawing our curve, we must cross n. We must cross n. So even if I wanted to, so let's kind of look at another version of this. So if I have my axes here, let's say I have a point here, and I have a point here, and I have this random value that's in between those here. So we have over here f of a, up here we have f of b, and we'll call this n. So in order to get from a to b, if my function's continuous, I'm going to have to cross n. Even if I wanted to first go down here like this, in order for me to get up here to b, right, to f of b, I have to cross through n, no matter what. There's no way for me to draw a continuous function and get from here to here without crossing through this value. Right? The only way that we would be able to do something like that was if I did something like this. Maybe I had a curve like this, and then it had an open circle there, and then a closed point there, and I went something like that. Whoops, something like this. Okay, yeah, that doesn't cross through n, but this isn't continuous, right? There's a jump in our graph there. So in order for us to be able to go from here to here and draw, if our function is continuous, then that means that it crosses every single possible y value in between f of a and f of b. So let's look at how we can apply the Intermediate Value Theorem and what we can use it for. So in this situation, it says use the Intermediate Value Theorem to show that there is a root, of f of x equals 2x cubed plus x squared plus 2 on the interval from -2 to -1. We do not need to worry about finding the root. What is a root? What does it mean when it's saying that there is a root? This just means that the value of my function is 0, right? It is 0 somewhere on this interval. A root is the same as a 0 or an x-intercept. Okay, so what conditions have to be met? So if we look back at the Intermediate Value Theorem, we need to know that the function is continuous, we need to know the endpoints aren't equal, and we need n to be in between the endpoints. Okay? So, So this right here, that is n. This function is a polynomial function, and all polynomial functions are continuous, and they're continuous everywhere. So f of x is continuous everywhere, which means it will be continuous on this interval as well. So because it's continuous everywhere, that checks the continuity box. What about the endpoints? What are the values of the endpoints? Are they equal? So what is f of negative 2? Well, f of negative 2 is, plugging it in, 2 times negative 8. Negative 2 squared is positive 4 and 2. So that's negative 16 and positive 6. So that gives me negative 10 there. What is f of negative 1? So negative 1 cubed is negative 1 times 2. That's negative 2 times, 2 times negative 1. Negative 1 squared is 1. So negative 2 plus 3, that's positive 1. So these two values are not equal. Is f of some number, so this would be f of c equals 0. Is 0 in between these? Yes. So we know that f of c is in between f of 1 and f of negative 2. Right? We know that this is 0. We know this is 1. Sorry, this is negative 1 here. This is 1, and this is negative 10. So because 0 is in between negative 1 and 10, then, and it's f is continuous, and these endpoints are not equal, then we have to say, we can say, that f of c must equal 0 somewhere. So f of c must equal 0 for some c in this open interval from negative 2 to negative 1 by the intermediate value theorem. By the intermediate value theorem. And it's because all of these things are true. It's continuous, the endpoints are not equal, the value that we're trying to find, it is in between those other two values.